In this video, we are going to be looking at using approximations and rounding to calculate a rough estimate for a calculation that is particularly challenging. Let's look at a few examples. Let's say that we're going to do 4,007 plus 1,998 over 2.03 plus 1.97. Now, without a calculator, this isn't very easy to do at all. However, what you can do is you can round each one to the nearest nice whole number. Usually, we round to one significant figure. If you need to, go back and look at the video I've already made on rounding to significant figures. Now, if I round 4,007, obviously this becomes 4,000. That's to one significant figure. 1,998 would become 2,000. And then 2.03 could become 2. And 1.97 could again become 2. So what I'm going to do is do 6,000 divided by 4. 6 divided by 4 is 1.5. 6,000 divided by 4 would be 1,500. Now, let's get our calculator and work out an exact answer. 4,007 plus 1,998 divided by 2.03 plus 1.97 is exactly 1,501.25. So you can see that we are really close between both of these. We're very close. The approximation is a good estimate. We can't say it's exact, we can say it's approximately. So we often use these curly equation symbols, the curly equal symbols, sorry. That means approximately equal to. Let's do another example. 2.03 times the square root of 9.13 divided by 1.87 squared. Now, 2.03 becomes 2. 9.13, we can't take the square root of that very easily. What I can do is I can square root 9, and then I can change 1.87 to be 2 squared. So that would give me 2 times 3 divided by 4. 6 divided by 4, 1.5. Let's put our approximately equal to symbols in, and now let's calculate an answer. 2.03 times square root 9.13 divided by 1.87 squared is 1.754. Now you can see that this approximation is not as good as this approximation. And the reason is that the rounding has been so much larger. I've changed 9.13 to become 9 and 1.87 to become 2. And as a percentage of the original amount, that change is much greater than in this one, where I changed 1,998 to be 2,000. That wasn't a very big change at all. Same with this one, 4,007 to be 4,000, and with the denominators as well. So the bigger the change, the worse the approximation is, and you need to bear that in mind. Let's do one final example. 1.87 cubed minus 0.95 divided by the cube root of 8.34. 1.87 cubed, we can't do very much with that, but we can change that to be 2 cubed minus 1, and then we can take the cube root of 8. So I'll get 8 minus 1 over the cube root of 8. 8 minus 1 is 7, divided by cube root of 8 is 2, so I get 3.5. Now let's work out the exact answer. 1.87 to the power of 3 minus 0.95 divided by the cube root of 8.34 in my calculator is 2.756. And you can see again that this isn't the best approximation because the 8.34 and the 1.87 have rounded quite a lot. This works much better for large numbers where you're not making a very big adjustment. When you're working with smaller numbers like this, your approximation isn't anywhere near as good. But without a calculator, it's the best way to do this because no one can really work out an answer that very quickly. However, using approximations, we can find quick answers.